All right, let's dive straight into this. Welcome to this explainer where we are literally pulling back the curtain on the Cambridge Mathematics AS and A-Level Syllabus 979. Specifically, we're decoding the examiner's playbook for Topic 4.2, Kinematics, really focusing in on differentiation and integration. If you want to know exactly how to secure your marks in this absolutely critical section, well, you're in the right place. Grab your notebook because we're getting right to it.
So, here's a really fascinating paradox. Why do students find applying kinematics concepts to unfamiliar context so incredibly hard? Think about it. This specific topic, differentiation and integration for kinematics, it pops up in literally every single examination series. You know for a fact it's coming. Yet the ability to adapt to unknown scenarios remains a universal pain point for so many candidates. It's kind of like martial arts. You can practice the basic punches all day, but if you can't flow like water and adapt to a live, unpredictable opponent, you're going to struggle. This is the #1 roadblock standing between a good score and a top-tier grade.
To fix this, we are going to systematically break down the examiner playbook into 5 parts. 1. Core principles of kinematics. 2. The procedural framework. 3. The method mark strategy. 4. Top examiner warnings. And finally, 5. Critical analysis and evaluation.
Okay, Section 1, Core Principles of Kinematics. Let's look at the actual cognitive domains you're being tested on.
Cambridge is explicitly targeting 3 distinct areas here. Yes, they want knowledge and understanding for sure, but they also heavily demand application and analysis. You're required to move way beyond just rote memory into systematic analysis and evidence-based reasoning. You have to prove to the examiner that you can think logically, not just regurgitate a formula you crammed the night before.
Because, as you can see here, top-performing students exhibit a connected, conceptual understanding that transfers anywhere. The goal isn't just memorizing rigid rules for, say, differentiating displacement into velocity and then velocity into acceleration. No, it's about possessing the sheer mastery to deploy those mathematical tools effectively, no matter what bizarre or unpredictable scenario the exam throws at you. You have to be ready for anything.
Moving on to Section 2, the procedural framework. This is how you actually execute that conceptual understanding on paper.
Examiners want to see a very specific, almost tactical progression when you approach a kinematics problem. Step 1 is tearing the prompt apart and completely deconstructing the question. Step 2 is extracting the relevant data from the given texts or tables. Step 3, you got to select the right analytical framework, like deciding whether you need to integrate velocity to find displacement based on the time intervals they gave you. Step 4 is executing your math with perfectly clear notation. And Step 5 is presenting your final answer with the correct terminology. Guys, this sequence right here, it's the structural heartbeat of a perfect answer.
And practical application in kinematics requires developing professional mathematical skills. Your presentation absolutely must follow strict conventions, proper headings, correct terminology, appropriate formats, and clear annotation. Look, data interpretation is only half the battle. How you communicate your findings to the examiner is equally critical to securing those top marks. If they can't read your logic, they can't reward it.
Which brings us to Section 3, the method mark strategy, the ultimate safety net. Now, before we dive into this absolute game changer, stop scrolling for a second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve their grade boundaries, so hit that subscribe button and ring the bell right now so you don't miss our weekly strategy sessions. Okay, let's get back to it.
Look at this quote. Even if your final answer is wrong, method marks can save you. This is a golden rule pulled directly from the examiner's playbook. In 4.2 Kinematics, candidates consistently lose marks simply by not showing their working. You must show your process, step by step, because marks are heavily awarded for your methodology, not just your final destination.
It is literally about process over perfection. Examiners want visual proof of your systematic problem-solving approach. Think about it. Messing up some basic arithmetic or forgetting that crucial plus C constant of integration at the very end won't completely destroy your score, provided you have clearly documented your logical mathematical journey. Show them what you're doing, step by step, and they will reward you for it.
Section 4, Top Examiner Warnings. Let's look at the most common student mistakes so you can avoid them.
According to the principal examiner reports, there are 3 massive mistakes that consistently cost students valuable points, specifically in the differentiation and integration of kinematics questions.
The contrast between what students actually do and what examiners expect is pretty stark when you see it laid out like this.
First, you lose marks when your approach relies on vague, generalized statements instead of specific, detailed mathematical reasoning. Second, you lose marks for poor formatting, where strict adherence to math conventions is expected. And perhaps most importantly, you lose marks when you just ignore the unique context of the prompt. Your answers must be anchored directly to that given context. You cannot just write down a generic kinematics formula, plug in some numbers, and hope for the best. It doesn't work that way.
Finally, Section 5, Critical Analysis and Evaluation. This is how you elevate your answers to secure those top-tier marks.
To hit the higher-order assessment objectives, examiners want to see you flow through this exact timeline. You start by identifying the given information. Then, break the problem down into logical steps and solve it systematically. But the top students, they don't stop there. Step 4 is absolutely crucial. Check for reasonableness. Does your calculated velocity or acceleration actually make sense in the real physical world? If a bicycle is moving at Mach 2, you probably made an error, right? And finally, Step 5, making justified recommendations or evaluations based on your analytical framework.
When you're asked to conduct a comparative analysis or evaluate the quality of evidence in a kinematic scenario, you've got to use this checklist. Explicitly identify any limitations in the data. Clearly state any assumptions you've made in your mathematical model, explore alternative interpretations of the problem, and crucially, measure exactly how these factors affect your final conclusions. And remember to use comparative connectives to highlight similarities and differences clearly.
So, now that you have the complete insider playbook, from mastering conceptual understanding to really leveraging that method mark strategy, the ball is entirely in your court. How will you adapt your strategy to secure every possible method mark on your next kinematics question? Are you going to keep losing points to simple formatting errors, or are you going to guarantee those points on exam day? Drop a comment below with your target grade for mathematics and the biggest challenge you're currently facing. And here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Like and share this video with a study partner. Thanks for tuning in, and I'll see you in the next one.